Welcome to September 2nd's LeetCode challenge. Average of levels in binary tree. Given the root of a binary tree, return the average value of the nodes on each level in the form of an array. Answers within 10 to the negative 5 of the actual answer will be accepted. Alright, basically that means that this parameter here means that we have to do some the average is a float, and make sure that the accuracy has to be correct. We have a binary tree here, and we'll want to find the average on each level. So the first level has 3, so the average of 3 is just 3 with 5 trailing zeros. Average of 9 and 20 will be 29 divided by 2, which is 14.5. And the average of 15 and 7 is 22, therefore the average is 11. And that's pretty much it. So similarly, we have the average being 3, 14, and 11. The constraints are that the number of the nodes of the tree in the range is between 1 to 10 to the 4 inclusive. The value of each node is between negative 2 to the 31st and 2 to the 31st minus 1. Alright, so the idea for this one, let's use a binary breadth first search to go through every level and calculate the average. Pretty straightforward. So the breadth first search solution, let's just start with a queue. And then we have, so we use a queue to do the first queue in the breadth first search, and then we have our output, which is going to be an array. And then we're going to have, the first thing we're going to do is queue dot append, and we're going to append the binary tree. So we got all that set up. So while queue exists, we loop through every level. So let's call this n being the length of the queue. Length of queue. Do we need? Yeah, let's do that for now. So the length of queue, and then we're going to have a temporary variable, which is going to store our current value. So we're gonna, for each index in the range of our queue, or length of queue, we loop through each element in the current level. So what we want to do is node is queue pop at 0, we remove the first element, and then we have a temporary variable which is going to keep our current value at each level. So this is a summation of it, and we're going to sum the node value. And then we, so this is basically on the same level. Then we need to check at the left and the right. Therefore, we need to append that to the queue as well. So in order to kind of continue our breadth first search, if node dot left, if the node is left, I should say, then we want to append. Let's see, if node dot left exists, then we append the left node to the queue. So node dot left. If the right node exists, so node dot right exists, that means that we want to queue dot append the right node. And therefore, we kind of add our queue as we progress along. We exit this if for loop. We exit this while the if statement, the for loop, and then we want to do output. So now that we have our sum, once we have passed this point, that means we have added all the sum of each level. Now we need to basically append the average to the output, and our average is going to be the temp float division by the length of our current level. So calculate the average, exit this loop, and once we return, we want to return basically our output, which should be the format of array that contains all our average for each level. Awesome. So this is basically I is big O of n, where n is the number of nodes in the binary tree. That's with time complexity. Space complexity is big O of n plus n plus n. So memory complexity would be big O of n as well, because we have to store everything inside all the elements kind of in our queue, all the nodes in a queue, but we also have another array as well, which is basically less than that. So big O of n on average for memory complexity. Alright, that's it. Have a great day, guys.